This is my good friend Kevin. He's an oceanographer and a research engineer. And this is the image he wants to portray of himself. Out on the ocean, working with these devices, these underwater robots behind him, programming them, collecting data for them, and generally doing science. But in fact, he tells me privately that he spends over 95% of his time here, hunched over in front of a computer, building custom software and analyzing data. Now, Kevin is a modern day programmer, and he had to learn to code in order to do his job. And I would argue that most programmers today are like Kevin. They're self-directed adult learners, whether they are engineers out in the field or folks from the social sciences or the humanities, such as these librarians and information scientists who are learning to code here in this workshop, makers who are hacking together physical wearable devices in order to build new sorts of interactions, or whether they're just traditional software engineers and programmers at companies like Google or Apple or these game companies that hold developer conferences and tutorials and workshops to constantly keep people up to date. So speaking of learning, let's go back to Kevin. So what did Kevin have to learn when he was learning programming? Maybe he had to learn some algorithms from textbooks like CLRS. Maybe he had to learn some software engineering, design patterns, the Gang of Four book. And then maybe he had to learn stuff about specific programming languages, like idioms in, say, C++. Well, I would argue that learning programming is not just about learning to code. So here's what Kevin really had to learn. First, he had to learn to code. Of course, he had to learn programming languages like C++ to interface with his underwater robots, programming language like Python in order to do some data analysis and machine learning, JavaScript in order to build front-end applications and interactive dashboards. And on top of programming languages, he had to learn some frameworks. So for JavaScript, maybe he had to learn Angular or React in order to build more responsive user interfaces. Then he had to learn how to work with data. So NumPy is a common library in Python for working with numerical data efficiently. Pandas, which is a layer on top of NumPy, which is for doing more data science-oriented work. Maybe something like TensorFlow in order to do machine learning. Then he had to learn about, say, JSON-based APIs. Then he might have to learn some data visualization. So libraries like D3 or Vega. But we're not done. So beyond learning to code and learning about data, Kevin had to learn domain-specific libraries like this cross-platform software for robotics research that he has to plug in order to power the underwater robots. He had to also learn things like Jupyter Notebooks in order to work in an environment where he can interactively process his data and explore it. He had to also learn something like pip, package managers for languages like Python in order to install and configure custom libraries, NPM, custom package managers for the JavaScript ecosystem for his front end, Webpack, things that compile his JavaScript and CSS and HTML together into modern apps that he can deploy. IDEs like Visual Studio Code, which have hooks into a bunch of these ecosystems in order to make him more productive. He had to learn about Unix and Linux command line environments, file systems, permissions, environment variables. But we're not done. He has to learn something like version control, something like Git and GitHub. And then finally, more and more stuff is now being done in the cloud in order to deploy his code online and run it more efficiently. And then he has to also learn, say, things like container management with Docker or Kubernetes in order to package up his code so they can run in the cloud. So I would say that modern programming consists of a lot more than code, right? So someone who has to learn programming nowadays has to learn code. They also have to learn about how to work with data. And they also have to learn about how to work with software environments. So learning programming today is about learning code plus data plus environment. The code part is pretty clear, right? You have to learn some basic set of programming languages, and you might have to also learn some frameworks. But then on top of that, I think modern programmers really have to learn how to work with data really well. So here's Kevin's example. So he has some underwater robots that he is interfacing with this cross-platform software toolkit, which it's itself written in C++. And that gets piped into, say, TensorFlow with the C++ API in order to do some machine learning. So that data as the output of the machine learning jobs gets fed into a JSON API, that itself gets consumed by Python code that interfaces with, say, NumPy and Pandas in order to do some more data science-y stuff on it. It also gets consumed simultaneously by a JavaScript front end that interfaces with visualization libraries like D3 and Vega in order to make an interactive dashboard. So code often interfaces with real-world data, whether it's Kevin's code out on the ocean, or the code that these librarians have to write to work with their information systems, or code that makers have to create in order to collect data from sensors. Code at any kind of company you're working with as a software engineer. If you're at Google or Apple, your software will interface with real world data. You're going to collect all sorts of data. You're going to output all sorts of data. Basically, if you're a modern programmer today, you must become an end user data scientist. So the term end user data scientist is an analog to end user programmer. So the term end user programmer is often used to denote someone who has to do some programming as a means to an end, but they are not doing professional programming. So I think end user data scientist is the right term here, because programmers have to learn how to do some data science-y things, even though their job is not to be a professional full-time data scientist. Okay, let's go back to our picture here with code. Learning to code, of course, is really important. And then, like I mentioned before, also learning to work with data. What I've often seen is that formal courses do a really good job teaching people the basics of programming languages. So a basic C++ course or Python course or JavaScript course. But then as soon as students step out of the course, they often hit what I call a cliff. They hit this immediate cliff of complexity where anything non-trivial they want to build, they all of a sudden hit this cliff where they have to now start learning how to work with the software environment underneath the code, whether it's package management software or cloud deployment software or version control. They hit this giant cliff where it's just so hard to do anything real, even though supposedly they understand the basics of how a programming language works. And I would say that programmers today are end user system administrators. Again, just like the end user data scientists, programmers have to learn a lot of system administration and software environment stuff in order to do their job, even though they're not going to become professional system administrators. Looking at this complex diagram here, I want you to think about, what will this look like in 5 years or in 10 years or wow, even like in 25 years? And here are some predictions of mine. So I think that programming will involve more multilingual code. Next, programming will grow more and more and more reliant on data from all sorts of real-world sources. And finally, programming will be on more complex environments. Today, we're pretty used to programming for desktops, laptops, and even for a variety of mobile devices like phones and tablets. But in the future, programming is going to be in environments like programming autonomous drones, programming our homes. All of these embedded devices, Internet of Things, smart devices are going to be in our homes that we can program. Programming our cars, whether it's peripherals in our cars or entertainment systems, or even the self-driving car algorithms, or even more scary, programming our own bodies, right? So we already now have a lot of wearable devices. Soon we're going to have implantable devices that actually go inside our bodies, and that's all going to be running custom code. And in essence, programmers will need to be code polyglots. They'll need to be really adept at picking up new programming languages on demand. Programmers will need to be data scientists, and they'll need to be end user system administrators in order to deal and grapple with all of these multifaceted environments. Here's something that keeps me up at night. So here is a paradox. As coding becomes more accessible, more learners will face these barriers. There's been a great movement over the past decade in particular about broadening participation in programming and lowering the barriers and making programming more accessible so that more and more people can get the benefits and get interested and get excited about it. And I love these efforts. But one consequence of these efforts is that the more people are doing programming in the future, more and more learners will face these barriers head on. So more and more people will reach the cliff of complexity where they learn all the basics of code, but then they run into all of this complexities of data and also of the underlying software and increasingly hardware environments. So they're going to find, wow, this is actually really hard to get anything real done, where supposedly I've learned, the basics of coding in this language. How do I actually get started working on anything real? So I think that the next generation of learning tools must take this complexity head on. Over the past decade, we've done a really, really good job creating learning tools for learners learning to code. But I think that taking on the complexity of data and environments will be a grand challenge ahead. So in sum, learning to code won't be enough. Learning programming means learning code, learning data, and learning environment.